I'm Vin Marshall, and I've spent the last 10 years building crazy machines and cool inventions.
Yeah.
Together with my buddies Paul Carson and Eric Gocke, we are attempting the toughest engineering tasks of our lives, using materials and know-how that anyone can get their hands on.
I'm ready for the greatest moment of my life.
This time, our task is to find out how hard can it be to send a rocket into space.
3, 2, 1.
I'm an electrical engineer and the mastermind behind the whole operation.
I like
Paul is a mechanical engineer. I've known him since high school.
This is actually really hard.
Eric Gocke runs his own construction company. We go way back.
It's yank this thing out, it's filled with nitrous, and push the button. 1.
So how hard can it be to send a rocket into space?
Everybody likes rockets, right?
What we want to know is how big a rocket can we make? We're going to start out with a simple toy like this, but then we're going to ramp that up to the biggest, nastiest thing that we can whip up in 3 weeks.
After all, it's only rocket science.
Sending a rocket into space is a huge challenge. For over 50 years, scientists have been trying to fulfill our desire to get off this planet and discover what else is out there. But rocketry doesn't have to be the domain of government agencies. I reckon we can build a serious rocket with parts anyone can get their hands on. We're going to start with the basics.
I'm about to demonstrate the principle of rocket propulsion. I have in my hands a fire hose connected to a large water truck. The water will come out of the fire hose in this direction and propel me backwards, just like the rocket exhaust goes down and propels the rocket up. I'm ready now.
This should be good.
Water spraying one way forces me in the opposite direction. This force is referred to as thrust. The more thrust a rocket has, the faster and higher it will go.
That is rocket propulsion.
Sending a rocket into space is going to be really hard. To get a feel for it, we've bought some hobby rockets. They're propelled by solid motors, which are basically a mixture of highly explosive chemicals, kind of like a firework.
This is one of the larger sizes that we could get our hands on. This should be interesting.
They get fitted into these cardboard rockets. One spark, and they're off.
Say fire in the hole.
Fire in the hole!
When the fuse is lit, hot exhaust gases shoot out the bottom of the rocket and generate thrust, just like the water jet. These rocket motors are great, but none of them have gone much over 1,000 feet. Eric's got one solution: more rocket motors.
I happened to notice when we were assembling this that there was space for a couple extra ones in there. So we put 5 in. And I don't know if that's going to work well, but I'm certainly willing to find out.
You ready for this? Should we use all of it?
All of it,
Let's
man.
go for it.
We're using some gunpowder to ignite the rocket motor.
Here at How Hard Can It Be, we
Morris.
advocate responsible use
Of gunpowder?
gunpowder, firearms, explosive devices. Don't ever do this at home.
In 5, 4, 3, 2, 1. Oh, please work. Come on.
It's definitely on fire.
Well, that could mean eventually it will work.
Sometimes rockets burn on the launch pad. Who would have ever thought that burning it wouldn't make it better?
Sorry, USA. I let my country down.
final launch of Endeavour.
Houston, Endeavour, all program. Roger, roger, sir. Endeavour, go at throttle up. Roger, go at throttle up.
For NASA, space begins 76 miles up. So we've got a long, long way to go to send a rocket into space. Still, at least we've made a start.
The motors we used on our model rockets were solid fuel motors. You light it, it gives off gas, the gas comes out the nozzle, and it propels the rocket up. These are great, but there's a problem. It's basically an explosive. In order to make one big enough, we'd need all kinds of approvals and licenses that we don't have.
It turns out there's a ton of websites devoted to home-build rockets. I found one that has a cool-looking design for something called a hybrid rocket motor. It's something we can build from easily available parts. 60, 61, 12 feet of it. What's great about this design is that we can build it without any special licenses.
A hybrid motor works like this. What it uses is a fuel that's a tube made of anything that burns. We need it to burn really, really fast to propel our rocket up. Here I have some wood chips, and I'm going to burn them. That burning is much like the burning that's going to happen in our rocket engine. The thing with our rocket motor is that it requires a lot more oxygen than the atmosphere can provide. So we'll be using another gas, which will provide a lot of oxygen very quickly. I have some here. Nitrous oxide, also known as laughing gas, has over twice as much oxygen as the air we breathe. This is it burning it with normal air. It's starting to go, you can see. And this is it burning with the nitrous oxide. The nitrous oxide runs out of this tank and into our rocket motor. That'll let our fuel burn really fast, which will give us our exhaust gases and propel our rocket up.
We also need some fuel to burn. Paul used wood chips in his demonstration, but we found out that we can burn regular plastic tubing we can get from the hardware store.
This is just regular old plumbing PVC. It's a little thicker and walled than what you might get for your house, but it's otherwise of the same composition.
We're going to start by building two small, simple hybrid rockets to test how well nitrous oxide and PVC tubing actually works.
Ever since we found out that you can make a bona fide rocket out of parts from the hardware store, we have not been able to rest until we see these things actually go off. This, the body of the rocket is just this EMT tubing. This is electrical conduit, like you'd run electrical lines in a commercial or industrial installation.
I've cut the EMT tubing to length. We're using it to make the nitrous tank and a combustion chamber where the fuel will burn. Paul's making the nozzle, which directs the hot exhaust gases straight out of the bottom of the rocket.
Our PVC-fueled rocket motors are nearly ready for testing tomorrow. All we have to do now is strap a nose cone and some fins to one, and we'll have a rocket that can actually fly.
See it, buddy. Does that look like a rocket? Was it worth staying here till 1 a.m., 2 a.m., whatever time it is?
Let's see what happens when we land it off, and then I'll tell you if that's the truth. We've come to the middle of the Mojave Desert to test our very first home-built rockets. This place is run by a group called Friends of Amateur Rocketry. It's kind of like Cape Canaveral. How hard can it be style. It might look like we're in the middle of nowhere, but this facility has everything we could possibly use for doing rockets. We have electricity, and we even have bunkers where we can hide from falling debris. This place is perfect for our needs.
We're here to figure out how well PVC plastic tubing works as a rocket fuel. But the trouble with launching a rocket up in the air is that it disappears out of sight in a split second. So we're going to strap one of our two rockets to a test stand so we can get a close-up look at exactly what happens to the rocket as it burns. We are also going to measure how much thrust it produces. To do this, I'm using a measuring sensor called a load cell.
So the rocket will push up against this like so.
When we fire the rocket, it measures the amount of thrust. If we produce more thrust than the hobby rockets, we're heading in the right direction.
We'll fuel up the rocket with nitrous oxide, but we have to do this remotely from the safety of a bunker, because there is a chance it could explode.
Just another one of those things I've always wanted to do. Get in a bunker to press a big red button.
It's a big moment.
Oh, I hear it. This is the first time that we're going to fire a motor that we've made. We're going to find out if we, know what we're doing at all. Three, two, one. I like everything about that.
Wow, that was good and loud.
Dude, this is awesome.
That was great. Is it hot to the touch?
Yes.
The PVC has burned really well, and it produced over 5 times more thrust than the biggest hobby rocket we launched. We've proven that we can build a rocket from store-bought parts. Now it's time to see if we can get our second rocket to actually fly.
We've borrowed a launch rail. This guides the rocket in a straight line during takeoff.
So, guys, I'm ready for the greatest moment of my life so far this week.
We've proved that plastic tubing works as a rocket fuel. Now it's time to test whether we can actually launch a rocket into the air.
Is that good, right about like that?
No, it's gonna be much higher, right?
I just can't wait to do this. But the cool thing about it is, if this works, we've basically got to go ahead to start building bigger rockets of the same design.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Wow, that's a real pop sound it made, huh?
The rocket went to around 3,000 feet. Not bad for a first try. We just got a little closer to our dream of sending a rocket into space. In the grand scheme of home-built rocketry, the hybrid rocket we just launched counts as a toy. We need to build a grown-up version. Not one that will get us all the way to space, but a stepping stone that will allow us to design and test all the components we need to get there.
And when we do that, pretty much all the components are going to remain the same, just bigger.
The new rocket is going to be about 10 feet tall.
Now, in our new rocket, we add a payload section.
The payload section will house cameras to video the flight, an altimeter to record how high the rocket flies, and a computerized flight controller which will deploy a parachute to bring everything safely back to Earth.
It turns out, getting a parachute to deploy reliably is one of our hardest challenges. I've bought a flight controller online, but hooking it up is gonna be work.
I'm testing out our flight controller. What this does is it fires off the explosive charge that releases our parachute and gets our rocket back safely.
If it fails to release the parachute, the rocket will smash into the ground at hundreds of miles an hour.
Hey guys, some of our rocket parts came in.
Oh, cool. Jeez, that's huge.
Well, not only is it huge, but this is just the payload section. So this is our rocket.
Now stand in the corner.
As well as the huge increase in height, the new rocket will be 4 inches in diameter.
Okay.
I gotta tell you, you say 4-inch rocket doesn't sound very big, but I guess they didn't say much about the tall.
There's going to be a fair amount of work to do in the next 2.5 days.
It's time to get building. The launch facility is manned by volunteers who all have day jobs. So we have to launch the rocket this weekend. In rocket speak, nitrous oxide is known as an oxidizer. We'll use 4-inch diameter aluminum tube for the oxidizer tank and combustion chamber. Building this rocket requires precision engineering. I'm measuring this part to within a few thousandths of an inch.
So this is the test that actually matters. This is just a short section, but this is the same material as the oxidizer tube. Yeah, there we go. Very happy with that.
Most of the rocket parts are ready. Now we need to assemble everything together.
Trying to set the electronics payload.
Vin and Gaki are getting the flight controller ready to go in the payload section.
Put this on one side of the board. Put this bad boy on the other side of the board. Okay, these guys need to be charged and they need cards.
This attaches onto here.
Yeah, that's okay. This is as together as it's going to get here, other than, we have to actually take it apart and charge these guys. But I think everything else.
It's installed batteries, it's plugged a few things in, it's yanked this thing out, it's filled with nitrous and pushed a button.
It's gonna be amazing. I mean, this rocket is really big. We expected to get to something on the order of 20,000 feet.
We are attempting to launch our 10-foot tall rocket to 20,000 feet. But launching it is only half the challenge. What we're also testing is the parachute that floats the rocket safely back to Earth. We've never done it before, and it's got to work perfectly.
Even though right now we think we've dotted all our I's and crossed all our T's, it's still a total crapshoot as to whether the thing's just going to explode on the launch pad, even with everything else done right.
This site is more than a great place to launch rockets. There are a lot of rocketeers here, and one of them, a guy named Jeff Jacob, is helping us today. This rocket is still only a stepping stone to space, so there is a lot to prove with this launch. We need confirmation that the motor, flight controller, and camera all work.
Now we've got 2 hours of recording on these guys.
The only way we're going to find out how high the rocket goes is if our delicate electronics survive. And for that, everything has to work perfectly, especially the parachute. If the chute fails, all is lost.
Good luck, guys. Try not to explode. You want to fire this one, or should I?
I'll do it if you want.
Okay.
Okay, ready for the countdown. 5, 4, 3, 2, 1, 0.
What happened? That didn't sound good.
The launch was perfect, but something's gone wrong.
Oh, Jesus. Is that our chute already off? We're coming down ballistically, aren't we?
Oh, man. That was bananas.
Are we in the bushes or are we on the property?
I think we're on the bushes and they may be on fire.
Let's go check this out.
This doesn't look good. Seconds after takeoff, the rocket spiraled out of control.
Oh, it's still hissing.
Whoa, look at that burnout.
The rocket suffered a catastrophic failure. Heat from the burning PVC and nitrous oxide has burnt a hole in the side of the combustion chamber.
You can see right there, it did its death
We got,
bounce.
this is supposed to tell us how high we got. Oh, let's see. Oh, yeah, we get the broken feet.
Here's one of the cards. Kind of jostled itself loose.
Okay.
This thing's still beeping.
Our rocket is a total wreck.
Is there anything else to pick up while we're at it? Just a bunch of...
The motor burned out before reaching 20,000 feet. The parachute did not deploy, and our cameras and data logging equipment are all in tiny pieces.
Well, that's kind of depressing, guys.
The people that saw it said that they saw it kind of start to shimmy like this and then just...
A hole like that'll make it shimmy.
So many things can go wrong with rockets, and any one of them is likely to mean game over. We need some help. We're going to see Jeff Jacob, the guy who helped us launch our rocket. Jeff lives, breathes, and sleeps rockets. He's been building them for over a decade. One look at Jeff's place tells me two things. One, we're in the right place, and two, we've got a hell of a lot of work to do.
This could take us a week to make just that part.
Well, I think this might be more than we can pull off. Are you going to be able to help us with your machine shop and your connections at some CNC machine shops to actually get these parts made?
I think that can be arranged.
Please.
That's good, because I don't think this is going to happen without that.
Yeah, I think we can work something out.
We need some...
The guys have a real difficult challenge ahead of them. That's going to be a lot of work and a lot of patience. I have a sample over here of a previously fired motor.
We used PVC as our rocket fuel, but Jeff prefers rubber.
An 8-inch rocket, and it's just basically a rubber. It's no different than the rubber on your car tire.
So once again, we're making rocket fuel out of just something you see every day.
It's cool to see all of Jeff's stuff, and I'm glad he's helping us, but it's not all good news. Even he has never got over 50,000 feet in 10 years of trying. Space begins over 8 times higher than that.
The last one we did was doing Mach 3, 2,100 miles an hour, and then we lost it at about 47 to 49,000 feet, and it's still out there in the desert.
It's time to get real. We found out we're not going into space. It's really far. It's a long way to space, and an amateur rocket from guys like us with our resources and our schedule, it's just not an option. However, if we can get over 50,000 feet, we get into the range where we have a pretty good chance of getting a picture or video of the curvature of the Earth. That is, this sort of sphere that we live on receding off into space. And I'll take that. That would be a great goal, and I'd be really thrilled if we could achieve that. We may not be going to space, but videoing the curvature of the Earth is still a massive challenge. Only a handful of people have sent rockets this high, so if successful, we'll join an elite group. To video the curvature of the Earth, we need to build a really big rocket. Our new one will be 10 times more powerful than our last one, which failed. It's gonna be a monster.
We're going to turn this aluminum tube, which is 8 inches in diameter, into the oxidizer tank. But first, we have to clean it.
So this is not how you clean your ears?
Not with acetone, no.
Jeff's come to give me a hand making rubber rocket fuel.
And as you can see, it's real thick.
We are benefiting from a decade or so of expertise he and his friends have developed, and skipping from our failed test rocket straight to building a Rolls-Royce of amateur rocketry.
I'm picking up notes of yuck.
We are adding black dye, giving the rubber its familiar color, and a kicker to help it set.
We'll have to be really quick. Make sure this gets mixed well and then gets put in our mold soon. Otherwise, it'll turn out to be a kind of gelatinous brick in the bottom of this bucket.
We've made a mold using styrofoam and a party bowl. it's a little bit worrying. I wish I'd made the holes a little bigger because this stuff is going to cure really fast, and we want to make sure that it fills this whole mold.
This is awesome.
So
We're actually making rocket fuel from scratch in our shop. The rubber is set overnight. I now need to dissolve the styrofoam mold using some acetone.
And it's slowly eating away at the styrofoam. I'm going to poke it with this stick. Let's see what's happening here.
When it comes to firing the rocket, nitrous oxide will flood into this end of the tube and ignite, burning the rubber from the inside out. The hot combustion gases will then exit at high speed from the other end, generating that all-important thrust.
Our rocket is so big, we've had to request special permission to fly it from the Federal Aviation Authority. They've given us the go-ahead, but we have to be ready to launch in just 3 days' time.
We've got a huge amount of work to do before then, and we can't cut corners. Building a rocket is an exacting task. Everything has to be precisely made, or the rocket just won't fly.
We have to put something like 500 or 600 holes that are drilled and tapped into these bulkheads. And if a single one of them has something go wrong, that we drill too far or break off a tap or anything like that, then it's back to square one.
So right now, I'm working on a piece that cost more than a few cars I've owned. And it's very scary, because if I screw this up, we don't get a launch. This high pressure work is endless. I now need to drill 200 holes partway through the section of the rocket. If I drill all the way through, I'll ruin this $2,000 part and set us back a couple of weeks, time we just don't have. In an incredibly lucky twist of fate, this cheap laying around chunk of PVC that we had slips exactly over the shoulder of my drill and makes a perfect depth chart. This should stop me drilling all the way through and make the task slightly easier.
We've got just 2 full days left to finish building our rocket. The main body and motor are coming together, but there are a number of key components we haven't even started on.
We don't even have our parachute thing figured out yet. We haven't even started mounting any of our electronics. We have a number of things that aren't even touched yet.
At the last launch, we'd hoped to test the parachute, flight controller, and camera systems.
We're coming down, boys, aren't we?
But the crash landing killed us.
Whoa, look at that burnout.
And now we have no choice but to use the same untested systems in this rocket.
Pretty robust. I wouldn't be surprised.
Oh, we blew off the power supply.
It's a real blow. Putting these systems together is painstaking work.
So I press it and hold it. And we're recording.
I can check how everything works on the ground, but I can't replicate the massive G-forces we hope this baby can generate.
And with any luck, this will survive many, many, many Gs. To save time, we've had our local metal shop make up the fins. They are designed to keep the rocket headed in a straight line. Certainly looks a lot meaner with this on. And now comes the all-important eye lining up.
Try squinting.
Yep, squinting works. Looks good. It's about 9:30, 10 o'clock now, but I can't put another rocket piece together until I've eaten some food because I'm getting really, really hungry. I could be leaving in between, 9, 10 hours. That leaves us, 9 or 10 hours to get work done. I don't know how much sleep we get in that time, but, This rocket's gonna be pretty cool. It's worth missing a couple hours of sleep for.
We're still not ready for the launch, but we've just got to add a touch of style.
Rockets look more rockety when they have rockety paint jobs. I've never spent so much time working on something that's gonna last so short an amount of time once it's doing what it's supposed to do. Tomorrow, the launch site. Now, we need sleep.
I got the USDA recommended 8 minutes of sleep last night. I think that's what it is, right? 8 minutes?
I just got 5 more back here, so I'm doing a little better.
This is our final trip to the launch site, and the pressure is on. The authorities have informed us we have to launch before 11 a.m. tomorrow morning, because after that, they shut down the airspace for military testing.
Here we are, another weekend at the rocket range.
Jeff hasn't seen our rocket since the day he helped pour the rubber fuel. We've done a lot since then.
Let's do it, guys.
I think this is where it gets worrisome, because this is where the rocket experts start going, ooh, yeah, about that.
That's not what I meant.
That's not really what I had in mind.
We got a little surprise. We
made some design choices.
Oh, look at that. We got tracking targets. Oh, you guys are unbelievable.
We were calling them racing stripes.
It seems like Jeff's impressed, and that makes me really happy.
Guys are doing great. You know, it's taken most of the guys out here several years to get where these guys have gone in just a few short weeks.
Thanks for the good report, Jeff. But the fact is, we still have a ton of work to do and less than 20 hours to complete it. We took the rocket apart so we could transport it safely, so our first job is to reassemble it. And it's absolutely critical we rig the parachute recovery system. We really should have sorted this out back in the shop. Now we've left it to the last minute.
I don't think it's ever good to finish your project too far in advance. You know, you got to be, for best results, you have to be working on it right up until the bitter end, I think. That's my policy.
Now we have to figure out how to pack everything into the rocket so the parachute comes out cleanly and at the right time.
I might have to pull them out.
They should all be splitting one, so it should be halfway in between.
It's really, really hard to get right, and one of the biggest causes of failure in amateur rocketry.
Is it going to go on top of this ship?
It's getting late, and this is the most important part of this project right now. We have our main rocket body and fuel worked out, but this is how we're going to get the thing back. Everybody's tired. The lines of communication are starting to fray.
Isn't this ring the only point of attachment?
I know you've answered the question.
This is what we do.
We're going to set it up, and we're going to do a dry run.
You're going to run the show, okay? Put pins on this, right?
After hours of discussion and trial and error, we think we've got it. At any rate, it all seems to be working in the benign conditions of our hangar. This rocket is a one-shot deal. I really hope everything works tomorrow. If the recovery system fails, the rocket will disintegrate on impact with the Earth. The cameras and all record of how high the rocket went will be destroyed.
So I think everybody's now satisfied with the parachute configuration. I think we give it one more sanity check, and then we're putting on the payload tube.
The payload tube is the last job for tonight. The rocket still isn't ready, but everyone's exhausted. Time to get a few hours rest and carry on early tomorrow morning.
We should have had it on the launch pad last night, and we obviously don't. So we really need to hustle this morning. If we don't launch by 11, we won't launch at all. So we've got to be really fast and really accurate for the rest of the morning while completely sleep deprived.
If we rotate it so I can see the markers.
I'm definitely worried. It's coming down to the last couple hours, and we got to get the rocket on the launch pad.
My last job is to fit a GPS tracker and a radio beacon into the nose cone.
This is how we're going to actually get the rocket back. So,
We have no idea where the rocket will land. It could be anywhere in a 5-mile radius from the launch pad. So these devices are really important. Without them, we stand little chance of finding the rocket.
Pretty quick, we'll pick it up, carry it out into the desert, put it on our stand, and get ready to fuel it.
I've got a bad case of rocket bug. It's been really tough, and we've burned plenty of midnight oil. But doesn't it look cool? It's 1 hour until our launch window closes. We should be loading the rocket with nitrous by now. But the GPS tracker isn't working, which means taking off the nose cone.
Our radio signal sender
Radio guy for Bruce
screws up
right
all
now
of our
because
reception
I
for our
can't handle those
GPS.
radios.
that's a distance that seems to work.
The fix is to try and space the two devices as far apart as possible, so the radio beacon doesn't interfere with the GPS.
Okay, that's our interface. Yeah, we're good. I'm going to run over to the guys with the other radio and verify that our beacon's still on. We know the GPS is still on. If they say yes, I can call this case closed. Can you guys wait for about a minute for me to go?
Jeff's ready to raise the rocket and begin loading nitrous oxide, but I'm slowing him down.
Man,
No, just do it.
Haul
Run.
ass.
Do it. and
Haul
assume it's fine.
ass. 10,000 questions.
Finally, the rocket is ready. This is it. The moment we've been waiting for. The onboard cameras are rolling. It's time to retreat to the bunker and begin loading 140 pounds of nitrous oxide into our rocket. We've got 45 minutes to launch our home-built rocket.
Okay, we got fuel going into the rocket. We've got about 20 pounds on board so far. Got about 120 more to go.
Loading nitrous is dangerous. It could explode. Tense moment.
Like if the rocket's like this.
This might be the longest 10 minutes of my life.
We got about 60 pounds of nitrous oxide on board. Okay, someone give us a time check, please.
We're in the second half of the fueling process, and hopefully it's nearing an end because we've only got 20 minutes left in our launch window.
So we cut this one down to the wire.
He's got 92 pounds of fuel on board now.
We're almost there.
We're moments away from our one shot at videoing the curvature of the Earth.
So that's basically it then, guys. I think we should just go ahead and fire this thing.
It's as full as it's going to get. We're going to set it off before we miss our window. We can't set it off at all. Okay, we're armed.
5, 4, 3, 2, 1.
The rocket climbs and climbs and climbs until it is completely out of sight.
thing I had.
That was the awesomest thing I was ever a part of.
I thought I had done awesome things before in my life, and this.
That was so cool.
I don't think I've ever been awestruck before.
Wow. Vertical speed of 1,335 miles an hour.
So 4 digits of speed, that means.
Dude, I was always happy with 3.
Eventually, the rocket begins to fall back to Earth.
Can you call that altitude? 13,000, 12,700, 12,300.
Does it tell you what the vertical speed is?
So the vertical speed is 114 miles per hour.
Is that consistent with the shoot out?
Altitude, 5,000 feet.
Right.
220 vertical miles per hour.
Yeah, it's speeding up.
31, 29, 27. Wow! 23, parachute should be coming out any second.
Oh boy.
Paul's computer is showing the rocket descending faster than expected. I fear the worst may have happened. The parachute might not have opened.
Nothing. We just had a report of an impact.
It sounds like the chute might not have deployed correctly because it came down faster than it should have.
117-8505. We're heading to the last known position logged on Paul's computer. But we've no idea if the rocket landed near there. We have to find it, or all our work is for nothing.
First, I'd really, really like it to come down and be in perfect shape and everything's the way it's supposed to be. But if barring that, I hope when it came down it only crushed the, the metaller section so that we have some of the payload left over.
We're not sure how high it went because it's going so fast that it couldn't maintain a GPS lock, especially as it gets to the top of its flight. We didn't pick it back up until it was at around 15,000 feet, which is...
And it takes a while for the GPS to resync itself, so who knows how long it had been falling already under the drogue chute.
If the memory card in the flight computer is intact, then we have a peak altitude, a peak speed, basically all the performance characteristics of this rocket.
GHB.
Okay, we got a lead from the trackers. They've spotted a basic impact area. We gotta be getting close, guys.
Well, we're getting a pretty weak signal on the tracking beacon. Oh, I don't want to be the bearer of bad news, but it's not looking real intact. Look at that.
Whoa, look
Nice
at
fire
that!
over here, too.
It tore right through the thin cam.
This thing really blew apart, man. There's pieces everywhere.
Yeah.
This is amazing. This is the forward bulkhead. The whole thing just smooshed together and then peeled back the tube. Wow.
Remember when these were straight?
Looking at our release system here.
The release link has fired,
No, that went off.
but the state of the rocket suggests the parachute didn't open.
We have burned black powder in there.
So we had the main chute should have popped out too.
Although,
Clearly it
it doesn't
didn't.
look like it did.
Without the parachute, the rocket smashed to Earth at over 200 miles an hour. But we've still got a lot to be proud of. The rocket flew straight and true and sounded like $1 million. Sadly, the camera cards were damaged beyond repair. But using video footage and analyzing the recovered rocket, we can predict that it reached a maximum altitude of 50,000 feet. The rocket produced over 18,000 horsepower, more than twice as much as a top fuel dragster. It accelerated from 0 to 100 miles per hour in 0.8 of a second and broke the sound barrier 5.3 seconds later. Our rocket hit Mach 2, or over 1,300 miles per hour, which is pretty damn awesome.
I'm in no way disappointed by this. I'm actually ecstatic. We didn't pull off a landing, but we pulled off what was, to me, seemed like a spectacular flight, and I'm really, really proud of it. It absolutely made worth not having slept very much at all in the last month. I would totally do it again.
It's totally possible that we videoed the curvature of the Earth. We just don't know.
So how hard can it be in a word?
Damn near impossible.
I'll say.